Alrighty, here we are again, back after Explore Las Vegas. Look in the audience, we've got a lot of people out there today. Looks like you missed us. Fantastic. Well, good morning, good afternoon, and good evening to our attendees out in EMEA. Speaking of EMEA, we're just a few short weeks away from VMware Explore in Barcelona, where we're going to be doing a lot of sort of double clicks on a lot of the things we're covered out in Las Vegas, but also bringing a lot of new technical deep dive. Plus, we have a lot of really good VMware customers and partners that are from the geo coming out to speak. So if you're in the area, please be sure to register, come visit. We look forward to seeing you. It's going to be a lot more technical content than you might have been familiar with Explorers in the past. So look forward to that. So just for the record, if you look in the upper right hand corner of the presentation screen, you can see an area where you can actually download materials, and in that materials you'll be able to get copies of the materials that are being presented today. Don't forget we have Q&A available. Lots of folks available for your questions throughout the duration of this presentation. And just as a reminder, in chat, we've got a link to a lot of our upcoming presentations. We are going to continue to keep the presentations coming for the rest of the year. We are going to slow down a little bit over Explore Barcelona, just so that we don't have conflicts, because I know a lot of our folks are going to be preparing for it the week before as well as the week of. We're going to go dark. But other than that, we're going to be presenting for the rest of the year with this program, as well as we're already shaping up the schedule for next year. So keep your eyes peeled. And again, that link is going to be in chat. Jamie Holbrook's with us here today. Jamie, you know, enough of me. It looks like we've got just about 200 folks in the audience that are waiting to hear from you. So let's go ahead and get you started.
Awesome, Matt. Thank you so much. And hello, and welcome to a new edition of By Engineers for Engineers, a live, no holds barred, unedited VMware by Broadcom podcast where we embrace all things technical. Today's episode is Moving Workloads into VMware Cloud Foundation with HCX. VMware HCX is an application mobility platform that simplifies application migration, workload rebalancing, and business continuity. HCX enables high-performance, large-scale app mobility to accelerate data center modernization and cloud transformation. I'm Jamie Holbrook, a solutions architect out of Atlanta, Georgia, focused on networking and security. And I'm joined today with my fellow solutions architect, John Matthews, out of Houston, Texas. Hey, John, how are things going today?
Doing pretty good today. Thanks, man. Just wanted to do a couple of housekeeping things. I know that Andrews kind of went over this, but use the chat for discussions. If you have a question that you want answered by the team that's on the call today, put it in the Q&A. Also, there's a PDF of the presentation that's going to be available in that little document-looking thing up there at the top as well. So, so today, I'm sorry about that. So today we have Tom Zukowski on the show. He's a fellow network solutions architect out of Michigan. Tom's a good friend of mine, and he knows HCX platform pretty well. In fact, I pull him into meetings when I get in over my head in some of those conversations. And Jamie, I know that you're kind of an HCX expert yourself, so should be an interesting conversation.
Yeah, it should be good. I'm excited for this topic as well. Tom and I have been working with HCX for many years now. I myself have had a customer that's moved well over 50,000 VMs with HCX, and I would argue between Tom and ourselves, we've probably had more than 100,000 plus VMs moved easily leveraging this tool. And with that, let me go ahead and turn it over to Tom and have him take us through this. So, Tom, the floor is yours.
Great. Thanks for the introduction, and let's move forward here. So what we're going to cover today is, just at a real high level, what is HCX? This isn't a 101 presentation. This is really somewhat of a deep dive, and we can dive very deep if you have questions about any of the material as well. But, we try to keep it at a design level. So we're going to talk about when you migrate your workloads to change the IP address, or do you keep them the same? And that might be different depending on if you're moving, into VCF into from the same data center. Maybe you're moving from a existing legacy vSphere stack into a new VCF environment. So you've got high throughput, but we'll talk about some of the reasons why or why not to change the IP addresses. and then talk about the different migration types that HCX offers. And then finally, we'll get into the deep pieces where we can talk about what's the, how to design an HCX environment depending on how many VMs you're going to move and what's your time frame. So first, and Jamie mentioned it earlier, but really HCX is a mobility platform. Most people associate it with migrations, right? Moving VMs from one vCenter environment to another vCenter environment. And it's really part of a process, right? In the next slide, we'll kind of talk to that HCX has a lot of integrations with other VMware products, right? We have integrations with operations and the former Verni product, now called the VCF Network Operations, right? To use that to build application groups before you actually migrate them, so you know what kind of dependencies those applications have. And so you don't move an application and then end up having to move it back because it had a dependency that maybe the latency between the old environment and the new environment was too great and didn't made the application not work correctly. So and then of course we've got HCX integration into NSX at the destination, and lots of integration points, whether you're managing the migration or monitoring the HCX fleet appliances or so forth. Very integrated system. So first, let's look at IP addressing, right? So this probably has more relevancy when you're moving into one of the vSphere public clouds, right, where they've got infrastructure stood up, and you're going to change. You're looking at changing IP addresses from a data center to one of the public clouds. But this also, could be an issue. You might want to start. Maybe you're doing redoing your network stack in the data center before you do the migrations. So you're going to move those workloads to different IP addresses. And really what some of the benefits are, and what you'll find, and depending on what role you have in your organization, application teams love not changing IP addresses. They like as few changes as possible to the application, really, to make sure it continues to work. Network teams generally would want to change the IP addresses. They'll build new infrastructure with different subnets and make sure everything's forwarding perfectly. And so there would really that group usually votes to change the IP addresses of the VMs. And so what are some of the things that are affected by that, right? Certainly DNS, right? If you're going to change the IP address, you have to change DNS, and that might seem like a not so daunting task, but then you run into customers. If your customers are reaching your applications, maybe their DNS cache doesn't refresh so quickly, so maybe they've got the old name to IP address in the cache, and it hasn't upgraded or updated in a while, and maybe the old name to IP address correlation will come up. So maybe you have some connectivity issues because of DNS changes. Some of the other things are load balancing, right? If you're going to change the IP of the VMs or the servers that are used for replying to a virtual IP address in a load balancer, that configuration would have to change, and certainly firewall changes, right? At the end of the day, a firewall is based on an IP address as either a source or a destination. And if you're going to change the IP address, you have to make sure that all those are accounted for. Worst case, allowing a lack of connectivity. In medium cases, you have connectivity, but maybe not all of the security that you have implemented or you had implemented previously. So it does take some time to do IP addressing changes, and we find with customers, can migrate much quicker without changing the IP addresses. And we usually, if you're under a time constraint, like you're trying to migrate workloads because you're evacuating a data center, and you want to move them quickly, that we find customers that don't change IP addresses can move more VMs at a time and move them quicker than customers that have to do all the planning for the IP address changing. John, did you have a question? Or
just had an anecdote on there, right? I had worked with one company that moved like 15,000 VMs from one data center to another. They had to evacuate a data center, and they changed all the IP addresses, so they just used bulk migration. So, and I had another one that moved thousands of workloads up into VMC on AWS, and they wanted to keep the same IP addresses. So it all depends on what your needs are. I kind of think it's nice that HCX actually allows you to be able to do uh, both of those things, depending on where you're coming from.
Great. Well, thanks. So this is a kind of an outline of what this network extension does. So HCX really has two main functions, I would say, networking and the second part is actually doing the migrations, right? Moving the VMs and then bringing them up, whether it's live or if it's after a reboot. So let's look at network extension first, and then we'll talk about the different migration types. So what HCX has is it really just it creates a layer 2 bridge, so that in my drawing here where we've got network extension, that's a virtual appliance. So up here we've got one network extension and another network extension here at the destination. So what that allows you to do is take this port group that's over here on the source site and extend it into an NSX environment at the destination site. The HCX user doesn't really need to know anything about NSX. HCX makes the call to the NSX at the destination site and creates that stretched network. Maintains the gateway that it has for that same subnet. So now my workload A and workload B have the same subnet. They have the same default gateway. This actually remains the default gateway, this source router here on the source side. And even though the workload is migrated to a different destination, really nothing's changed as far as IP forwarding other than this layer 2 bridge now between sites. So let's look at this in a little more depth. The next slide. Sorry. So each of those network extension appliances can extend up to 8 VLAN. In the picture, I've got VLANs, but as a vSphere or vCenter user, a VLAN is associated with the port group. So those, again, 8 port groups can be extended across a one pair of appliances, and you can scale these appliances up to 128 appliances, network extension pairs, or if you're using HA, which I'll talk about in a couple of slides, that it's 64 appliances. So really, you can have hundreds of VLANs stretched. We don't recommend that. If you have a use case that requires that, absolutely, they're supported up to the amount in configmax.vmware.com. But the idea would be stretch a network, migrate the VMs, and then unstretch the network. And that's kind of the ideal case. It's very difficult for customers for whatever circumstances, but that especially if you have a mix of physical servers and virtual servers on the same subnet, that can't be your method of doing migrations. But certainly you can have these VLANs up for long periods of time as well. So sorry, John, do you have a question?
I actually had two, so I think you already answered one. You can leave these things up, right? So it's not just
absolutely.
Yeah. Okay. Cool. So that's good. But what if somebody has like large bandwidth between the two sites? Is there a way to expand the? Well, there you go. Yes, you can.
Absolutely. So I said up to 8, but it's really any mix of 8. We have a published bandwidth or throughput of 4 to 6 gigabits. I've got a slide coming up here in a couple of slides that talks about how to increase that. But if each of your networks, or if you want to limit each of these network extensions to maybe 2 or 3 networks, and then they share that 4 to 6 gigabits over 2 to 3 networks, that's an option as well. So you can create as many pairs of these up to that 64 with HA enabled. And certainly we recommend enabling HA. That's a relatively new feature in HCX. HCX has been around for years and years, more than 5 years. It's changed names a few times, and there used to be a couple different versions of it. There was an advanced and an enterprise, and today we have really just the feature set that is in the hyperscalers that includes all of the HCX features. And in VCF, there's no more advanced in enterprise. It's the entire feature set is available via the VCF licensing. So again, you can really design this how you like. Customers in the early days found that, hey, this is in a data plane. So, when you upgrade these appliances, they go down and, you have an outage. So we had to come up with a way to to work around that. So, Jamie, did you have a question?
Just something that came up in the Q&A that, maybe the broader audience would like to understand is like, the question is NSX required on both sides? And so at some point, you maybe want to dive into that. But the short answer was it's only required in the destination. But as you're showing here, the source side can be VLAN back networks. And if we're stretching, then we're going to go to overlays. But maybe we're noting that we can still do the migration, as you notice, as two components and not have to land on the NSX network.
Absolutely, and I probably didn't mention that very clearly up front. That like I mentioned, there's two parts of HCX: a networking piece, and then there's the migration piece. You can use HCX for just migrations. You can use HCX for just stretching the network, or you can use a combination of them. You don't have to stretch every network. Sometimes there's a high priority networks. I'm in Michigan. We have a lot of manufacturing sites, right, that have applications that are one, maybe they're even based on IP address, so you don't want to change the IP address. But then you have applications that you don't want to mess with because nobody knows, anything about them, but they just work and they run some kind of assembly line that, you don't want to have any downtime. So again, so back to where I had left off about network extension is this idea that, we needed something to create redundant paths. So because eventually you'll want to upgrade these appliances as part of their life cycle. So we came up with this high availability where we have two pairs now in the green. The pair with the green dots would be the active path, and the pair with the red dot would be the kind of the standby path. Both of them are active, but the standby path is not forwarding any traffic. It's just doing health checks back and forth between peer appliances on the same site and the partner appliances between sites. And there's a failover of half a second there's a health check every half a second, and if we miss 3 health checks, then they would change the forwarding path from the network extension 1 path to the network extension 2 path. So it will fail over fairly quickly. So we've a new feature actually right in the latest release 4.10 came out a while ago, and one of the kind of the limiters in that 4 to 6 gigabits was that we had always had between those appliances we had encryption. So as it's leaving the appliance on the source side, traffic's encrypted, so that adds some overhead, some compute overhead to processing the traffic that's being forwarded, and not only overhead of compute, but it also adds a header to the packet that's being forwarded. So now the packets that we're sending has a smaller payload, so we're actually sending less the data because some of the headers increase some of the header eats up the packet size. So what we find now, what you can do is, and because the HCX originally came up with to really do migrations over the internet, right? So this has been around for years when there was low bandwidth, not private connectivity to these large vSphere cloud environments. You were either going to another private data center or something, so you needed the bandwidth, and many customers used bandwidth over the internet because that was less expensive than a point-to-point circuit. So now we have the option to turn off that encryption. So especially if you're doing migration within a data center, right, within the 4 walls of a building, or you have a private circuit between 2 locations, it's another option. You can turn off encryption, so we'll get that processing back because we won't have to do the encryption. We'll get larger packets, or the packets won't be larger, but the data packets will have more of the migration data and the network extension data per packet, because we won't have the header of the encryption. So again, it's an option, and you have to set that up when you configure HCX. And there's a warning saying, hey, this is non-encrypted. Make sure this is a private network. but we are seeing pretty good performance improvements. I know the marketing number is 7 to 8 gigabits, from the old 4 to 6, but in some cases we're even seeing more than that. So another thing to think of is again, if you're looking at increasing performance. So we have two ways, just in scale the number of network extensions, and then even turn off encryption, and then you'll get a higher throughput. So I just wanted to kind of do this at a high level. So we've got VMs in two different networks right at the source side. We migrate some VMs to the destination, and then we do our network extension. So now the blue VMs, the VMs on the blue network are in the same network still. Same thing with the VMs on the purple network. And if a VM wants to talk to a purple network, VM wants to talk to a blue VM network, it has to go back through that network extension path between the two sites, and it still will use this first hop gateway over here on the right hand side. Let me kind of give a little point to that. Right, so this is the default gateway for the VMs on both sides, and sometimes depending on how what's the latency right between here, that may affect the application performance, and it might not affect the network application performance. So, John, do you have a question while we're on this slide here?
Yeah, I think you're going to get into it. There was a question about what happens with the gateways on each side, and if we have to actually trombone everything all the time. So I think that's what you're getting to.
Yeah,
You may beat me to the punch.
No, that's a good thing, and I'm telling you, like, that's not always a bad thing. And again, you usually have a discussion, right? Network teams don't like a hairpinned drawing like this. This is looks bad, right? But again, if the latency, if it's a metro, you're going from a data center across town, maybe that latency is 10 milliseconds, and nobody would really miss, or that application would not show any effects of that latency. The nice thing about it is, if you've got firewall rules here on the source side between the blue network and the purple network, right? So I've got all of these policies that dictate what traffic can pass between there. If I use this hairpinned environment, I don't have to change any of the firewall rules, right? Because my VMs are the same address. I don't have to move any firewall rules at this point, and maybe it's early in the migration, so you keep this environment. Eventually, you want to take these firewall rules, especially if you're evacuating a data center, you'll have to move them over to the destination side. But so in this kind of thing, the security team says, "Yep." The network team says, "Yeah, I don't like it so much," and again, the application team says, "Oh, I like it because I haven't had to change anything on my end." But we do have an option for customers that would like local forwarding. I call it. It's whether it's routed or bridged. It doesn't matter. But I'll just use the generic term forwarding. So the network extension has another feature called mobility optimized networking. That's a mouthful. So from here on, I will just use the term MON. That's the acronym for it. And what happens is the NSX over here on the destination side is a multi-tier networking, multi-tier routing architecture. So if you want to think of this becomes the gateway over here for VMs that are on the destination side. VMs that are on the source side still use this path, and VMs on the destination side. So now everyone can forward traffic, or all of the VMs at the destination can talk to each other, and all of the VMs at the source. Still, if my blue VM wants to talk to a blue VM, they still use the path that we had earlier had shown in the thing. And again, this is all done just by clicking a box. You enable MON over here on a network, and HCX tells NSX what to do. It programs this at this level of routing. So again, very little interaction with NSX while you're using HCX. And John, go ahead.
Yeah, quick question. Is there a limit with MON on how many /32s we can insert, or
Yep,
that you know of?
That's great. Today it's 1,000. And
Okay.
that's grown. It was 100, and I think 200, and now we're up to 1,000. So, and the great place to check for that in new versions would be this, the config max, right? So
Yep.
configmax.esp.vmware.com, that gets updated with every version of HCX that comes out. So that's
Okay.
1,000 VMs. Um, and so you apply that at the port group level, and then you also apply MON at the VM level. So if you know that VMs are going to talk to, like this, we'll say this is VM1 and this is VM2 and they're on different networks, those would be good candidates for MON because they're on separate networks. But if you've got, 50 other VMs that are on the blue network and all they talk to is via other VMs on the blue network, there's no real reason to enable MON on these, 3, 4, and 5 because they're all just talking on the blue network. MON's really beneficial when you're talking from one subnet to another subnet at the destination.
Okay.
And
So something to keep in mind when you're doing your planning and your cutovers, right?
absolutely. And again, that my second or third slide there that talked about planning. The more you plan, the better success you have. And there's no easy way to accommodate all of these things, moving parts. It's while HCX certainly helps and simplify some areas. You really you need to do some planning. Okay, so after just kind of talking about those different networking features, and again, that's an option, right? So if you decide you're going to change IP addresses and you don't need to do the layer 2 extension, you can also do layer 2 extension if you're in the same data center. Physical switches can do layer 2 extension as well. It becomes a little more complex if you're not going to move the gateway, or some other networking manufacturers might have some ways of doing local forwarding, but so you certainly have that option inside a data center. If you're going to one of the vSphere clouds, then the physical network extension, I have not seen that that's an option anywhere. It's really HCX is the only way to do that. HCX or NSX, I'll say. NSX has a native function of doing layer 2 extension as well. So everyone says, how many, I've got 1,000 VMs and I've got to move by such and such a date. How quickly can I move them? Well, everyone knows the real answer, right? It depends. And it depends on a lot of different things, right? It depends on the storage and the IOP capability, at the destination, the CPU and RAM on the host, of course, just anything that you would really have to deal with in a vSphere environment, right? Network infrastructure is another thing. So there's a lot of different things that how quickly can I migrate these VMs? The answer is it's always depends, right? If someone gives you a quick answer, we do have some guidelines in the user guide. The HCX user guide is a really awesome guide, and there are a number of blogs, and I've got a slide at the end that we're not going to go through in the presentation, but if you download the PDF, you'll be able to see those links to some really good HCX documentation. So let's go through these migration types. These are the main 3 that we're going to hit, because what does HCX do differently than, say, cross vCenter vMotion, right? So cross vCenter storage vMotion, right? So I go into vCenter and I say I'm going to vMotion this, pick the storage, pick the cluster that the destination is, and it goes, right? So it moves the data, syncs memory, and then the VM becomes live, right? And there's after all those things are done, then it's live at the destination. The main thing that HCX does as far as migrations is it separates moving the data and doing the switchover. So what we call switchover is when the VM becomes live at the destination. So if we look at bulk migration, for example, so bulk migration will as soon as you start that job, it'll start moving the VM. But then you can schedule when you want that VM to come live. And really, both of these, the first 2, have that scheduling capability, and they both work off of a live VM, and they have different transfer mechanisms, right? And the kind of the switchover is what's really different, right? So where we've got a warm migration under a bulk migration, that's because the VM does reboot, so it goes down when it goes from the source side to the destination side. replication assisted vMotion does the same thing. You schedule the data move. The data gets moved and it gets synchronized every so often. And then, but when we do the switchover, it's live. It's actually a vMotion. So there's two pieces. There's moving the data, and then there's the switchover piece. I put the latest in here, maximum number of migrations that can be queued up, right? So on a manager level, you can do 1,000 migrations. At the IX or the appliance level, right? So there's a replication appliance that I will get to here in another slide here coming up, but the appliance replication is 200 per IX appliance. And you see I've got a caveat about here, HCX manager scale up. So that's kind of one of the newer features is like a lot of our tools at VMware, right? They're virtual appliances. So we need more resources, we add more CPU, we add more memory. So there's guidelines for that. There's actually 3 different sizes of managers now. And if you go to the larger size of the manager, that's where the 1,200 comes into play. HCX assisted, I've got a slide on each one of these, so I'm just going to kind of run through this quick. HCX vMotion, the biggest difference between that and cross vCenter vMotion is that HCX vMotion goes back. I mean, it used to do 5.5 and 6.0 VSX. Right now it goes back as far as 6.5, right? So you can do a vMotion between 6.5 and 8.0 update, whatever the latest is. And then there's always cold, right? So cold's just basically a way to transfer powered off VMs. OS assisted is actually, we have kind of an interesting feature that we're not going to talk about other than this one point here where if you've got resources that are VMs that run on Hyper-V, or you've got them that run on KVM, HCX can actually do that. They can transfer them, migrate them from existing hypervisors into vSphere. So go ahead, John, you got a question?
Yeah, I just wanted to. I think you said this, but I wanted to make sure I heard it right. So, what is the oldest version of ESX that you can go from, and then to the what's the 2? And I guess the 2 is the latest, right?
Yeah, 2 would be the latest, and the 2 is always going to be a supported vSphere release. So you couldn't migrate something into 6.5 or something like that, because once it reaches end of support, the destination has to be something that's a supported release. On the source side, you can have older releases, like 6.5 is the latest that we support.
Okay.
With the primary migration types that I mentioned.
Okay. Awesome.
And then that runs out in November 15th, I think, when the day that 6.5 is, I believe HCX support ends about a year after the regular support for the ESXi. Jamie,
Okay.
you have a question or a comment?
Yeah. One comment, one question. I would say, while we were talking about migrations, this is a question you and I get asked a lot. It's like, well, I've got cross-center vMotion, why wouldn't I use that? Why HCX in these different migration options? So it's a common one we get. I was just wondering if you want to kind of address that. And then I did have another question after that.
Yep, I do. Do you want to, how about that? Because I'm going to talk about these different migrations in a little more depth, and I'll hit your how does it differ from cross vCenter vMotion? And I mentioned it a little bit already. Is the big thing is that we separate the data transfer, right, time, so you can do that, and then what happens, for example, here's in the bulk migration, right? So bulk, when you click on a HCX job, and again, whether it's 1 VM, 10 VMs, or up to 200 VMs, and you do a bulk, what happens is HCX copies the full VM over to the destination, and then it does a delta sync every 2 hours. So it's going to have, within 2 hours, it's going to have the current any disk changes that have occurred. And then with bulk migration, what happens is we shut the VM down at the source side, do one more sync, and then we boot up the VM at the destination side. So there is a reboot, right? So there's the time that's down at the source side and comes up at the destination side. But the idea is that you could start. One of my peers always says, migrate on, or do the replication on Monday and then do the cutover on Sunday, right? So you can be doing these the copies and the synchronizations all week long, but then Saturday night when you do the migration in your maintenance window, that all you're doing is powering off and powering on the VM, right? So you can do many more VMs, and this is a really efficient way to do it. As long as your workload can take the reboot, right? If it doesn't have to be on all the time, bulk is really a good way to do migrations, because most of the data is going to be there within that 2-hour window, and we're basically just powering it up.
Yeah, and
So
that switchover is a great differentiator, that the scheduling of the window. While we're here, this may be a good time to ask one of the questions that was in the Q&A. Is a couple of people have been asking about the new VCF import capability, and what would be the difference between that? So is that something you kind of want to talk about here? Because I think what you're showing here is the ability of moving, and we can have a net new clean environment. That's the unique differentiator as opposed to import, where I'm just ingesting existing vSphere clusters, and that may not be configured the way you would ultimately like, but might be something you wanted to
right,
cover as you're going through these migrations.
yep. That's was yeah. So I haven't really followed the kind of the new import with VCF, but absolutely, that would probably be something that again you could use in a data center, but you wouldn't do that inside of going into VMC or AVS or something like that as well. But and so if you have any, Jamie, if you have any more comments about the import feature, please add on. But what with replication assisted vMotion, the big difference is now when we do the switchover, it's actually a vMotion, so it's a live migration, right? It syncs the disk, syncs memory, and if there's changes, that it's just like a vMotion. If you've got a VM that's changing, it's gonna take some time to make sure that the memory and the disk is synchronized before it does the live vMotion cutover. The latest and newest type of migration is actually, I think, going to be very handy when you're doing intra-data center migrations, right? So what you have somewhat of and in the Hcix architecture that I haven't shown the slide yet, but there's a replication appliance on both sides, right? So you're using that, and that has a throughput limit and a processing limit. Again, which copying data isn't such a big deal, because in the two migration types I've mentioned previously, they've you copy that ahead of time, so most of the data is already there before you do the switchover. With Cross vCenter, you copy the data and then it switches over. There's no like breaking those pieces up, and that's what we have with HCX assisted vMotion. But it's basically HCX is managing, monitoring, archiving, keeping logs of what's going on. But HCX is really just telling vCenter on the source side, hey, you're going to do a storage migration to this VM and put it at this destination. So HCX is kind of managing it, but it doesn't use the IX appliances to do the replications. That's what this is kind of for bulk and RAV, this is the flow right through these IX appliances that do the replication. When you were doing HCX assisted vMotion, HCX is just saying, hey, vCenter, we're going to do this, migrate this, and it's actually a host to host, right? So I've got a ES6i host here and an ES6i host on the destination side. So it's very efficient. It's much you can actually take advantage of high bandwidths that between the physical host. So it's a very thing. But the issue then is when it does that, it does it right now. So you start that job Saturday night, and it does the switch over right after it's done copying the data. So if you've got high speed infrastructure and you can move that VM data, there's a trade off, and that's one of it depends, right? So you can do X number of VMs between your midnight and 4 a.m. maintenance window, but you're going to have to do the data copy from scratch using the HAV method. If you're doing RAV, for example, again, like I said a number of times, most of your data is going to be there, so it's just going to be the switchover that's occurring between noon and between 12 and 4 a.m. for example. So you have to try it really, just see which one works better in your environment. Cold and vMotion, they're basically the same thing. vMotion, of course, is live, and cold is a powered off VM. So there's nothing too exciting about these. So let's look at some of the design pieces here. I know we've kind of covered the networking piece. We've covered the different migration types, but let's see how this all fits and works together. So one thing, I didn't really have a good place to put this slide, but I'll put it right in the front here. And HCX was actually one of VMware's first connected services, right? You had to, when you licensed or when you created an HCX manager, it would go out to these two, well, it would go out to the activation URL, and that's kind of what I'm showing up. Let me get my pen here real quick, right? So this is connect. So the HCX manager went up there and kind of started the service, right? So that's how HCX was activated. And then we had another connection to this hybridity depot, so that anytime, 4.9.1 comes out and you're running 4.9, HCX learns that, hey, there's a new version coming out, and you see the banner in your HCX manager that says there's a new version to download. So for one version of HCX, we had this air gap where this was optional. You didn't need to connect here. So anything 4.8, and less 4.8 and less than, this was an option. It wasn't an option, right? You had to connect to these two URLs. So if you were a site that didn't have internet connectivity, HCX wasn't an option for you. At 4.9, it still worked. You still were able to reach these two, but you also had the idea when you would install the OVA, you could click air gap and it would allow you to not connect to these two. And now at 4.10, these are no longer there. So 4.10, when you would go install HCX, you have to go download the connector manager and the cloud manager and install them separately. They do local activation via license, and if you're using VCF, then the activation is a little bit different than if you're using NSX and that licensing. But now 4.10 and beyond, there's no internet connectivity required. So that's a big change. I just wanted to make sure if you used HCX before, you don't need the internet connectivity any longer. Okay, so I mentioned there's some of these appliances already. We talked about network extension. So this is basic HCX architecture. Everywhere you have a vCenter, you'll have an HCX manager. On the source side, it's called a connector. On the destination side, it's called the cloud. And the cloud requires NSX. So you see I've got over here on the right-hand side, I've got vCenter and NSX manager. You can use NSX at the source side, but it's not a requirement on the connector side. And when you build this out, what happens is when you install this connector manager, and then you pick which HCX features you want to use. Do I want to use RAV? Do I want to use bulk? Do I want to use network extension? There's a couple other features that we didn't have time to get into today, but anything that you enable, then you tell HCX, this is what I'm going to use, and HCX goes and it builds out these other virtual appliances, right? So you have an OVA that you create the manager with, and then you tell the manager, I want to use these same three features, and it will build out these appliances. So if someone picks network extension, it'll build a network extension appliance. And you actually tell it, if you're going to use network extension, how many appliances do I want to start with? Maybe I just want to start with one. Or maybe I know I'm going to extend 10 networks and I want one appliance per network. So then you just tell HCX that you're going to start with 10 and it'll build 10 of these appliances. And then the same thing with the interconnect appliance or IX appliance, as I mentioned before. If I'm going to do bulk or if I'm going to do RAV, then it will build out one of these appliances. And one of these replication appliances can really do the replication for a specific cluster. So if you're going to migrate a cluster, or if you're going to migrate a whole data center. And this is part of like where we're going to go with this design type architecture discussion in the next couple slides. It used to be we're limited to one of these IX appliances per cluster. So if I had a data center, and again, a data center in terms of vCenter, right? So I've got vCenter, I've got data center in the cluster, and then my hosts and my VMs. So at the vCenter cluster level, I could only have one IX appliance. So that was kind of a limiter, especially if I'm trying to evacuate a data center. I've got a lease and I'm trying to get out of it. You're limited to the throughput and the processing that one IX appliance could do. If you're just migrating some VMs, you don't care how long it takes. You can do one IX appliance that can service a whole data center, right? So I've got 3 clusters. I can just have one appliance service all 3 clusters. Well, so we've changed that here in not so far away, or not so long ago, so that now what you can do is so anyway. So this what I forgot to mention was this grouping of network extension and IX appliances is called a service mesh. So if you're familiar with Kubernetes, or you might have heard of service mesh before, but so this is a service mesh is this grouping of appliances, and you could kind of think of them as even like a microservice, right? It's a server appliance built for a certain service, right? So I've got network extension of this. So this combination of appliances on the source side and the destination side is we call that a service mesh. And now what we can do is say in my example about 3 clusters, right? So I've got vCenter and I've got 3 clusters. Well, actually, no. Say this is cluster 1 and this is cluster 1. But now I can have 2 of these service meshes or multiple service meshes per cluster, right? So if I really want to evacuate VMs quickly, I could have, say I've got say 1,000 VMs across my cluster. I can send 500 of the VMs to be migrated that way and 500 of the VMs to be migrated that way. So you get it's a manual step, and so that allows you to control it. So when you create a job that says I'm going to migrate this group of 50 VMs, I can send all 50 here, or I can send 25 here and 25 here. So you kind of select which path it's going to use, in which service mesh it's going to use. So this is a big difference. John, do you have a question?
I just want to make sure I got this right. So, so you got a vCenter on site A and a vCenter on site B. Inside of that one, you got multiple clusters, but inside the same cluster, you can put multiple IX instances, so you can actually have much greater replication going from site A to site B.
Absolutely, and that's a newer feature.
Okay, yeah, I didn't even know about that one, so that's cool. And then of course we have the network extender that we can do. We can have multiple ones of those too per segment. So, well, 1 per segment kind of thing. If you want to,
you could.
So we're just continuing to improve this to make your evacuations from old data centers to new quicker. This is cool. Just want to make sure I understood that.
Yep. And then again, if anybody on the call has used HCX previously, and that was a limitation for you, now that limitation's gone. That one I'm going to skip. We do support migrations within the same vCenter, and we still have the appliances just like we had when we had 2 different sites. But again, so this could be used. It really just depends on how many VMs you're going to use. If you've got VMs and you're just moving from one cluster to another cluster in the same vCenter, then perhaps just cross vCenter vMotion will work for you. But HCX is also an option. Now, there's some network considerations. We talked about extending a network between 2 sites, and what we get often, right, is a customer. I'll use VMC as an example, but again, it's VMC, AVS, any of the vSphere clouds. You have multiple SDDCs, right? Because you want to have some high availability. You can extend the same network. So here's your source over here on the left-hand side. You can extend a port group from here to 2 different SDDCs in VMC, two different, maybe two different regions, two different availability zones, but you can extend that network. And we allow you to extend that up to 3 different places, right? So this is what we support. And we do up to 3. Now, just because you can do something doesn't mean you should do something, because again, all these links will have latency, and you really want to, something you want to test, make sure the application is okay. Having VMs in the same subnet at different locations, right? So just again, the tool allows you to do it, but you want to make sure the application works. One thing I run into a lot is customers will have, maybe they have two data centers. And what you'll see is in networking, you never want to create a loop. So we'll say, okay, well, so I've got 2 sites. I can do this again with HCX, and I can extend them like that. What you have to watch is if the customer's got already like a network extension at the physical network. And we'll show a picture of this in the next slide coming up here. But this is important because now this is a third leg, and if this is going to close so if I draw over the top of this creates a loop, right? So if I've got site 1 and site 2 are connected to each other, and now they're connected to the same SDDC, now we've got a networking issue, right? So we've got a loop, and that would be a bad thing in the network. So make sure if you've got any data center to data center connectivity, you take that into account when you're doing network extension. This is just another kind of derivative of what we just showed, where we've got data center going to an SDDC and then going to another SDDC. Maybe this is the high-speed link, between 2 SDDCs. You're going across the AWS backbone, right? So there's my 2 SDDCs. Same thing, that supported configuration. You cannot add one more leg to this L architecture, just the 2. This is kind of what I talked about on the previous slide, but I think it's a little more easy to see. But again, this doesn't take into account that you might have some connectivity between a site 1 and a site 2 that aren't on the picture. But that's pretty common that customers, especially if their data centers are, in a metro data center or something where they've got maybe some fiber connectivity between them. So we're going to talk about, next slide is kind of I say usage tips, but things that you take special care in feeding. And I know we get these questions a lot from customers, and I don't know if anybody's added any questions on the chat about special use case migrations that anybody wants to add or ask the question out. Nope. Oh, hi, Leslie.
Hey, Tom. Yeah, so what about the use cases where customers want to be able to migrate between different migration types, for example, between like Intel and AMD or vice versa?
Yeah, that's a great question. So you can't do a live migration between different architectures like that, between Intel and AMD, but you can certainly use bulk. So bulk allows you to do that because it does a reboot, right? So it does a reboot, so it can understand that it's different CPU architectures. Even within same Intel, sometimes you run into this where customers got brand new servers and they're going to connect to AVS, and maybe the AVS servers are a little older, different older Intel architecture. That it's the same idea as you can't do a live migration between those, but you can definitely do bulk migration to those. Thanks. So that's kind of, I guess we can just run through these. Databases, are difficult to move. We've got different ways to do them. If you can shut down the service and make them less chatty, that certainly helps, right? So you're not syncing memory back and forth. I worked with a customer yesterday. They've got a 42 terabyte database they're trying to move, and even with the services shut off, it's been a challenge just because of the bandwidth and the checksums that go back to make sure, hey, we moved the data. Is the data the same size as it is on-prem? And so that type of thing. That takes time and some compute to actually to check that and make sure it's the same. So, John, did you have any comments or questions?
Yeah, I was just going to say, in general, databases have their own kind of data replication or duplication that they can use to where they can create another service on the destination side, synchronize that stuff up, and then start using that database over there instead of just trying to move that VM from site A to site B, because that makes life really difficult when you try to do the move. So there's other
Great.
options to do stuff is the point.
And the next one on my list here too is something that you run into. Customers, they want to move their Active Directory servers. Well, even Microsoft doesn't recommend that you migrate them like this. What you should do is you should build new ones, and then inside the Active Directory servers, there's ways to migrate a service, right? So you've got a number of services running on the domain controllers. Then you migrate the services. You migrate a service, check, make sure it works, and then you shut the service down on the original side. So those, we don't recommend those. It's a VM, you can do it, but it's in practice, the way that they work is you really want to create new ones. And there's a number of examples. These are the kind of the ones I thought up when doing the slide. We do not let you migrate vCenters or NSX managers, right? So that's part of the control plane. You don't want to have part of the control plane, out of sync with other parts of the control plane. So again, the idea would be to migrate into a different vCenter or a different NSX manager than your source. So this is one that Leslie's question about different host architectures. This one we just come up with a bit. We had a customer where they were doing, they're migrating to AVS in this case, and they're evacuating the data centers. So they've got a number of data centers. They're moving all of the VMs. So what happened is they migrated all of the VMs off of the hosts where they have the IX and the network extension appliances running. So they wanted to move those to a different cluster in the data center because they're condensing hosts in the data center. So over time they've migrated a lot of VMs. So they wanted to just vMotion the appliances. Well, again, it's a VM. You can do a vMotion to the appliance, but what happens is in that service mesh definition, you have to tell it, well, which cluster you're going to install the IX and the NE appliances. So what happens if you were to ever upgrade the service mesh or reboot the appliances, it would go back to the service mesh definition and say, I'm supposed to be in this cluster. And if that cluster is gone, so what really the recommendation is to build a new service mesh, and then start using that service mesh with different appliances in the new cluster, and then deactivate the old service mesh and just start using the new service mesh. In their case, they were using network extension, so there's an outage to do that. To you'd have to unextend the network and then re-extend it over the new service mesh. But that's really the best way to do it and the controlled way to do it. And then I think I've got the backup servers, right? So backups. So when we do that, we migrate the data, and then we do that sync every 2 hours, right? We use a change control block, right? So to see when that file was last, what changes have happened in that data file since the last 2 hour sync. So you want to stop your backups, because many backups, that's how they do it too. They look at that control block. So if we're doing that, and then your backup server, your backup solution tries to do that, it's going to say, I haven't touched it. Something else has touched it. Now you're out of sync. So, John, did you have any questions or comments? I know we're just about out of time here, but.
Yep, we were just running up at the top of it. So I was just gonna bring this to a close. It looked like that we had hit the end of the presentation.
Yep. No, perfect. And there's the PDFs available for this. The PDFs, actually, the links I put in here work. There's a lot of great blogs out about customers and VMware people that have used HCX. And so if you're trying to do something, Google it or use my list here. This is just a fraction of them. And some of my peers and I, we're going to start doing a boot camp for HCX. So if you're interested in doing a boot camp, might be 3 hours of lecture and 3 hours of lab using hands-on lab. Keep an eye out for that, because probably within the next 30 days, we're going to start doing that.
Yeah, that's cool.
Shameless plug. Sorry.
I did your boot camp. It's awesome.
Yep. Yeah,
Uh,
we've done it internally, for the first 8 months of the year, but now we're going to go customer facing.
cool deal. Well, Tom, I think thanks much for spending the time with us today. Appreciate everybody coming on. Jamie, did you have any final thoughts?
I'll just say there was a lot of activity and obviously a lot of interest, which is great. I mean, you may not be able to see on my shirt, but HCX is near to my heart for sure. Definitely a solution I love. I would just recommend, as Tom said, we've got a lot of great resources, but, reach out to your VMware by Broadcom team. Tom and I are still part of these teams. We have these conversations on a daily basis, typically. We're here to help you. And, again, just based off the question, it looks like there's a lot of activity still for HCX, and anything we can do to assist, just let us know. And thanks, Tom. Excellent job.
Yeah, thanks for having me, guys.
Awesome. Much appreciated. Thanks everybody for joining up, and we'll see you on the next one.